So here we go. This is talking about industrial robots. So we're done with safety now. We're going to start talking about robots. So we're going to do a whole bunch of graphs here, graphs and statistics, talking about a bunch of different things in this presentation here right now. So questions you're going to be looking for here. What is the definition of an industrial robot? Who are the major manufacturers of industrial robots? Some of these names you'll be familiar with, some of them you might not be. What are the major countries or regions that are using industrial robots in the world today? And what are the major industries for industrial robotics? Those are all things that you're going to be asked to answer on your assignment. So what is an industrial robot? There's actually a definition for this as per the ISO 8373 standard. Three main points here. Automatically controlled reprogrammable multi-purpose manipulator in 3 or more axes. So a robot is a machine. A robot is reprogrammable, meaning that it can be given new instructions to meet changed requirements and perform new tasks. And a robot has a multi-purpose manipulator, which means it can be used in different ways. So it's not just the 6-axis articulated robots that we have in our lab. There are lots of other machines that are considered robots by this definition. Most of the information that's in this comes from the International Federation of Robotics source here. There's one document that I found that's really good, where a lot of this data came from. So, what are the different manufacturers of industrial robots that you'll see out there today? A lot of different names. You're probably familiar with some of these. The big ones that we will see and that you're going to get familiar with. The number one that you will see, ABB. This is what we use in our labs. That is what we have. So you'll be learning ABB robot programming in terms 2, 3, and 4. You might also get a little bit of FANUC in there as well. We do also have we have 2 Yaskawa robots in our lab, but we don't really use them very much. A lot of these other ones you'll see out in industry, but we don't deal with them in our labs. So KUKA, Kawasaki, Nachi, Kamau, Panasonic, Adept, and Denso. You'll see lots of those around in industry. But we do not have any of those in our lab. So ABB is definitely the big one. You will get very, very familiar with ABB. And you'll also get familiar with the fact that you can tell different types of industrial robots by their color as well. So you'll get familiar that yellow robots are FANUC. Orange robots, typically ABB. You can kind of tell what they are just by looking at what color they are. So who is the world leader in market share? If you look at this graph here, this comes from 2011. It shows Yaskawa, FANUC, KUKA, ABB as the top 4 in there. That's as of 2011. Some more recent data. I found this one here. This was from a source called Asian Robotics Review. It says world or global numbers for 2020. FANUC being number 1, Yaskawa, Motoman number 2, ABB number 3. This is pretty accurate to what you would see around here. One thing I know from dealing with local industry around here, you will definitely see that FANUC here, they are definitely number 1 in this area. Probably about 50% of the robots you'll see around the Southern Ontario area are going to be FANUC. ABB, also very big around here. Nachi, very big around here. Those are the main ones that we see in this area in particular. But FANUC and ABB, probably the 2 most useful ones to learn and to be familiar with in this area. Get rid of those. So our robot sales actually growing right now. You can probably take a guess at this, what it's going to be. Here is some numbers from 1995 to 2013. As you can see, pretty steady increases all along the way here. You can see one big dip here in one obvious dip in 2009. You can probably guess why that is. That is the what they call the Great Recession of 2008, 2009. So stock market crash there, economic slowdown. Probably going to see that for this year as well with what's going on right now. But definitely a big dip in industry worldwide in 2009. That's what causes this year. So let's look at some more recent numbers. We stopped at 2013 there. You can see general, just regular increase all the way through here, leading up to what's projected to go to up to 2022. This data was accurate up until 2018. That was just projection after that. But I always ask people, do you think there's going to be more robots or fewer robots in the future? Obviously, more robots. So, general increase there. And by region, so where are these things going? Where are robots being installed? You can tell that by region. Definitely going to Asia, Australia. You can see that is the blue column here. That dwarfs everything else in the world. So Asia and Australia are the big users. Europe is in red. That is the next biggest user. And then the Americas are in the gray there. So North America, South America lagging behind the rest of the world. Asia is definitely the largest user overall. And if you look by country, you can see China is dominating everything. Probably China is probably equal to the rest of the world as far as markets as of 2018 for total number of units installed. So China installing a ton of robots, basically. China, Japan, United States next after that, Korea, and then Germany, and you'll see an awful lot of European countries in here. But China is basically the driver of all of this. Now this is a really interesting one here. This is robot density in manufacturing. So what this means is how many robots do you have per 10,000 actual manufacturing employees. So this takes into basically consideration of how many manufacturing employees there are. When you look here, Singapore, for every 10,000 employees, they have 831 robots. So there's about almost a robot for every 10 workers in manufacturing in Singapore. Korea just behind them as well, and then a huge drop after that. So basically Singapore, Korea, extremely automated. Now what's interesting here is people always relate automation to jobs. And they think if you're automating things, putting in robots, you're taking away people's jobs. If you look at the unemployment numbers of these countries as well, all these countries that are over here, extremely low unemployment numbers. Singapore is about, I think, 2.1% unemployment. I had that on another graph. I should put that in here. Korea, also extremely low unemployment. All these countries over here, very low, up until you get to Italy. Italy was, I think, about 9% or something like that. But everything over here, extremely low unemployment, which goes against the commonly held belief that if you're automating things, you're taking away people's jobs. Very low unemployment by these highly automated countries. This is Canada over here. And then what are people using robots actually for? Types of jobs that they're doing. Material handling is the big one right here. That is the most common one being done. Welding, second most common. Assembly is the third most common. So those are the three big ones there: material handling and welding and assembling. And those are the primary skills that we're going to be teaching in our program here as well. And then in what industries? Automotive, you'll see, is the leader up there right now. Electronics, catching up quite a bit as well. That has changed over the years. Electronics is being very highly automated now. And then metal and machinery, and then everything else down below there. But basically automotive and electronics are the two big ones there. Okay, so that gives you kind of an idea, an overview of what people are using robots for, where they're using them, and some of the different tasks that they're being used for. So in our next lecture, we're going to cover some of the history of robotics and what those, kind of where this has all evolved from. Okay, so we'll see you later.